So today I'm here with lecture 2, right? Lecture 2 of chapter 1, right? In lecture today, first I'm going to discuss potential due to system of charge, right? Yesterday I calculated potential due to a point charge, right? So what was the formula? Suppose this is a charge q, right? So potential charge q kept at this point, right? So potential at point P, which is at r distance from this one, is how much? Potential, suppose this is your point P. So potential at P due to this charge is how much? Kq by r. So this is due to one charge, right? If one charge is present, then potential due to that charge at some point will be kq by r, right? But today I am going to discuss potential due to system of charge, right? System of charge means many charges present, right? So potential due to system of charge. Potential due to system of charge. Okay, so this is for potential due to single charge, right? But now system of charge means many charges is present. Okay, so now you can see, suppose this is the point, right? At this point we are going to calculate potential, right? And many charges present. One charge is present here, right? And this one is separated by r distance. This is one q1, right? Similarly, another charge is present here. This separation is r2, right? Another point is present. Another charge is present here. That is suppose q3, right? And this separation is r3. Similarly, n number is present, right? And suppose similarly this is your Rn, right? And potential at this point, potential due to this one, we have to find, right? So this is your charge n. Now you can see n number of charges present, right? And we have to find potential due to all these charges, right? So now first I am going to calculate potential due to this charge, right? So now you can see these two charges separated by how much distance? R, right? So we are able to write potential how much? kq1 by r1. Yes or no? Right? So first I am going to write potential at P, right? Potential at P. So I am going to write potential at P due to charge. Potential at P due to charge 1. Potential at P due to charge 1 is charge 1 V1, right? And this V1 is kq1 by r1, right? Similarly we can write potential at P due to 2, right? What value will come? That is V2, right? And that value is q2 by r2, right? This way also we can write for V3, and V3 is how much? kq3 divided by r3 dot. Similarly we can write Vn is equal to kqn by rn, right? So now we calculated potential at P due to all charges, right? Okay, so now total potential at this point will be the sum of all these potential, right? So now I am going to write total potential, right? Okay, so now I am writing here total potential at point P. Total potential at point P is V, right? And that V is equal to V1 plus V2 plus dot plus Vn, right? All value is known to you, just we have to substitute the value, right? So V1 is how much? kq1 by R1 KQ2 by R2 plus dot 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 KQN by RN, right? Okay, so this is your potential at P due to system of charge, right? So this way you are able to find potential at a point due to number of charges. Okay. So next I'm going to take one example on this formula. Okay, so first I have to write the question on the blackboard, and after that I will solve the question. Okay, now you can see I written the question. I'm written the question on the blackboard. Okay, so two charges. These two charges is separated by 15 centimeter apart, right? Okay, and we have to find a point where electric potential is 0, right? Okay, so 2-point charge, this separated by this much, and we have to find a point where electric potential is 0, right? Now suppose this one is your one charge, right, and this is your another, right, and both is separated by what distance? 15 centimeter, right? Suppose at this point potential is 0, right? Okay, suppose at this point potential is 0, and this distance is how much? X, right? So at this point potential is 0. At this point potential is due to this charge as well as this charge, right? So total value of potential is 0, right? That things are given, and we have to find what is the value of X, right? And this charge is given. Suppose this one is first one, this is your second one, right? So first one is given Q1, right? And Q1 is given how much? 3 into 10 to the power minus 8 coulomb, right? Q2 is also given. Q2 is equal to how much? Minus 2 into 10 to the power minus 8 coulomb, right? So potential at P, suppose this is your P, right? So potential at P is mainly due to both charges, right? Now we can write here potential, total potential, okay? Total potential at P is V, right? And this V is how much? Potential due to 1 plus potential due to 2, right? And in question given potential at P is 0, given V is equal to 0, so this value is 0. That means V1 plus V2 is equal to 0, right? So further we can write V1 is equal to minus of V2, right? Now you are able to add the value of V1, right? See, these two charges separated by how much distance? So we can write here V1 is equal to K Q1 by R1. Similarly, V2 is equal to Q2 by R2, right? K cancel, right? And similarly, further we can write K cancel. Q1 is how much? Q1 is 3 into 10 to the power 8. So 3 into 10 to the power minus 8. And R1, this separation is your R1. Yes or no? This separation is R1. R1 is how much? X. So X is equal to Q2 is how much? Minus 2 into 10 to the power minus 8 minus 2 into 10 to the power minus 8, okay? And this separation is how much? Total is 15, so this separation is 15 minus X. So this separation is 15 minus X. So 15 minus X. Now you can see 1 minus is already present here, no? Minus B, and minus B is how much? KQ1 by V2 is how much? Minus V2, right? And V2 is how much? KQ2 by R2. So minus is 1 minus is already present here, right? So 1 minus will come here, right? Now you can see these 2 minuses becomes plus, right? So after this I'm writing here, okay? In this place I'm able to write, okay? So now here some value we are able to calculate. 10 to the power 8 minus 8 is cancelled by 10 to the power minus 8, right? Now 3 by this side only 3 by X. and other side how much is the value? This minus becomes plus. That means 2 by 15 minus x. Now cross multiplication and find the value of x. So cross multiplication. So 3 into 15 minus x is equal to 2x. So now this value becomes 45 minus 3x is equal to 2x. Now we have to shift this one to other side, right? So that value becomes 45 is equal to 5x. So x is equal to 45 by 5, right? We are able to cancel it. So how much coming? X is equal to 9 centimeter. X is equal to 9 centimeter. So we can say that at 9 centimeter from this charge, at 9 centimeter from this charge, electric potential is 0, right? Okay, we got the value of x is equal to 9 centimeter, right? Okay, but one more value of x is also possible, right? What is that? In this calculation, I have chosen point P in between these two charges, right? One point is also possible in this region, right? In this region where electric potential is also 0, right? Okay, so now I am going to find that one, right? Two value of x is possible, right? One I calculated, right? Another value of x will come in this region, okay? So now that one we are going to calculate, right? Okay, now here two value of x is possible, right? Another we calculated, right? Okay, when point P will lies in between these two charges, right? And another value of x is also possible, right? In that case, point P will lie in this region, right? Point P will lie in this region, right? Suppose point P is at x distance from this one, right? So again, potential at P will be potential due to 1 plus potential due to 2, right? And right, so further we can write V1. How much is the value of V1 now? This is the separation, right? So further we are going to write V1 is equal to K Q1, right, by R1 minus K Q2 by R2. So again you have to write all these things, okay? Again draw the figure, again write from here, okay? Two value of x is possible. So now I'm going to calculate another value of x, right? So now here you can see kk cancel, right? Kk cancel. So q1 by r1, right? Q1 is how much? 3 into 10 to the power minus 8, right? R1 is this length plus this length, right? So 15 plus x and minus, and Q2 is how much? Minus 2 into 10 to the power minus 8. Minus 2 into 10 to the power minus 8. This minus becomes plus, right? And here what value will come? X will come, right? Now this minus becomes plus. 10 to the power 8, 10 to the power 8 is cancel, right? Okay, this minus becomes plus, right? So further now I'm going to write here, okay? Now I'm going to write here. So now we have to go for cross multiplication, right? Here what is present? 3 by 15 plus x is equal to minus into minus plus, right? And 2 divided by x, again cross multiplication. So 3x is equal to 2 into 15 plus x, right? So 3x 30, yes or no? 30, 2x. So further we can write 3x minus 2x is equal to 30. So x is equal to 30 centimeter. So now see, this time x is coming how much? 30, right? So 2 point is possible, right? At which potential will be 0. One will lies in this region here, right? And that is At how much separation from this one? 15. Sorry, 9, right? And another will lie in this region. Okay. So this way we are able to calculate both value of x at which potential is 0, right? Now potential due to an electric dipole, right? So electric potential due to an electric dipole, okay? Now, so dipole, right? Dipole is known to you. Dipole is combination of two equal and opposite charge, right? Suppose this two is the equal and opposite charge, and these two charges, this combination of these two charges is known as dipole. Okay, this is minus q, this is plus q, right? Midpoint of dipole, this is midpoint of dipole, this is center of dipole, right? And we are going to find at a point P. Suppose this is your point P. At this point we are going to find potential, right? Now this is dipole moment, right? Dipole moment is direction of dipole moment is negative to positive, right? And suppose this is a r vector, right? R vector is position vector of that point at which we are going to calculate potential, electric potential, right? Position vector of that point at which we are going to calculate potential with respect to center of dipole, right? And angle between these two is given. Angle between r vector as well as p is given theta, right? And now we are going to find potential at this point, right? So suppose this one is your R2, this one is your R1, right? Now potential at P will be the potential due to negative charge as well as potential due to positive charge, right? So now I am writing potential at P due to plus Q, right, is V plus Q, and that V plus Q is KQ by R2, right? Because you know potential, formula of potential is KQ by R, right? So this separation is how much? R2, right? This separation of here we have to write minus, okay? Okay, here we have to write R2 now. So this separation we have to take now, and this separation is R1. Sorry, we have to take R1, right? So you know the formula V is equal to KQ by R, and R is the separation between those 2 points. So this separation is how much? R1, right? So we can write like this. Similarly, potential at P due to minus Q, right, is V minus Q, and that V minus Q is KQ minus KQ by R2, right? This separation is how much? R2, right? So we are able to write like that, okay? So now total potential, right? Total potential at P, it's summation of this potential as well as this one, right? So total potential at P is V, right? And that V is summation of potential due to plus Q plus potential due to minus Q. Yes or no? Yes. And this value is given in the question, that is KQ by R1. Yes. Similarly, this value is given minus KQ by R2. Now you can see here KQ, I have taken common 1 by R1 minus 1 by R2. Yes or no? Right? Further we can write like this: KQ is R2 minus R1 divided by R1 into R2. Suppose this is your equation 1. Up to this, there's no doubt, okay? Now, well, how we can calculate value of this one, right? So now we are going to find value of this one, right? So for that one, now I'm going to do some mathematical things, okay? So this is only your physics, right? Now I'm going for mathematics, okay? Mathematics for what? To find value of this one, R2 minus R1 divided by R1 into R2, right? That one we are going to calculate, okay? So first write this part and write up to this, and then I will draw one more diagram, right? Okay, I hope you written all these things, okay? So now I'm going to do something in this diagram, okay? So just see what is that. But you try to draw another diagram, right? No need to do all those things in same diagram, right? For mathematical purpose, you have to draw another diagram, right? No need to write in same diagram, okay? I am drawing in same, but that things is not for you, okay? So you have to draw another diagram, okay? So now I'm going for mathematical only, so I'm removing the charts. I'm removing physics things, okay? Now you can see we have to find R2. R2 is this length, right? Now do one thing, extend this one in this direction, right? Suppose I extended up to this, right? I extended this one in this direction, right? After extending, draw perpendicular from this to this point, okay? So this is perpendicular, right? I drawn perpendicular, right? Now you know total length of dipole is 2a, right? So this length is how much? A, yes or no? This length is A. This length I'm talking about, this length only. This length is A, right? So this length is A. This angle is theta, so this angle is also theta, right? This angle is theta, this angle is also theta, right? Okay. So now you can see. This length is A. So this length will be how much? A cos theta, right? So this length is A cos theta, right? Now but why I am calculating this value? Because this value, see, this length is equal to this length, right? So from the diagram we can write R2 is equal to R. Here to here how much? R, right? Here to here how much? R plus this length, right? R plus this length, and this length is how much? A cos theta. Okay, so next I have to find this length, right? Okay, so again if you are going to draw perpendicular from this point, this one to this one, right? So this is perpendicular, right? So now this length is equal to this length, right? So from here you are able to write R2 is equal to R minus A cos theta. Similarly, you can see now this length is A cos theta, right? This length is A cos. Okay, now you can see how R1 here, R1, how R1 is coming? R minus A cos theta, right? How R1 is coming? A minus. So this length is somehow equal to this length, right? This length is equal to this length. This is not clear by diagram, right? But this length is approximately equal to this length, okay? Now this length we are going to find. This length only. Just see my finger here to here, right? Here to here is basically this length minus of this length, right? So that's why I wrote R minus A cos theta, right? Now R1 is known to you, R2 is known to you, right? So just substitute the value in this one and get the answer, okay? So further after this I am writing here from equation 1. From equation 1, right? From equation 1 we can write V is equal to KQ R2. R2 is how much? This much. R minus R plus A cos theta, and This is how much? R1, right? R1 is R minus A cos theta, right? And bracket close, right? And in denominator what value will come? This one into this one, right? R1 into R2. So R minus A cos theta, and similarly R plus A cos theta, right? Now you can see here plus R. If you are going to open the bracket, this becomes minus R, right? So further I am writing like this: KQ R A cos theta minus of R plus A cos theta, right? And in denominator you can see R minus A cos theta and R plus A cos theta, right? So further we can write it R square minus A square cos square theta, right? This R is cancelled by this R, right? A cos theta is 2A cos theta, right? So further we can write, now I am going to write you can see this is KQ, A cos theta and A cos theta is 2A cos theta, and in denominator what value will come? R square minus A square cos square theta. So B is equal to this much is coming, right? Now this quantity is known to you, this is your P, right? So further we can write K P cos theta by R square A square cos square theta. Okay, so final formula for B is coming this much, right? Right now, generally it is found that A is very smaller than R. A is very smaller than R. So A square term is very smaller, right? So we are able to neglect this part, okay? So we are able to neglect this term, right? Because A is very small, so A square is also very small, right? So this term is, we can neglect it, okay? So further we can write B is equal to Kp cos theta by R square. So this is your formula to potential due to electric dipole, right? Okay, potential due to electric dipole, right? Sometimes this formula is also written in vector form, right? So suppose if you are going to write in vector form, so you can write like this: Kp vector dot R vector, unit vector along R divided by R square, right? So this way you are able to remember it, okay? So this is your formula to calculate potential due to electric dipole, right? So just try to remember this formula, and if question will come, then you try to calculate the answer, okay? Okay, so next I am going to discuss potential difference, right? Potential difference is the difference of potential between 2 points, right? Okay, so next potential difference, right? Potential difference, okay? Potential difference, okay? Difference of potential is known as potential difference, right? So we can write the difference of potential between 2 points is known as potential. The difference of potential between 2 points is known as potential difference, right? And potential difference is represented by delta V. This quantity represents potential difference, okay? So next we are going to write relation between potential difference and work done, okay? Work done by external, okay? So next, now I am writing here relation between potential and work done by external. So mark at the start and write it: relation between potential and work done, right? So what is the relation, right? So relation is very simple, okay? So difference of potential, that means V final minus V initial, V final minus V initial, right? And this V final minus initial is W external by Q, right? So this is relation, just you have to remember it, okay? So what is W external, what is Q, and this one we are going to understand, right? Suppose this is your initial point and this is your final point, right? And one charge Q is here, right? One charge Q is kept here, right? And now I am taking this charge Q to this point, right? So in taking charge Q from this to this, right? I am doing how much work? This much, right? So this is your W external, right? W external, right? So work done is known and charge is known, then you are able to calculate difference of potential between these 2 points, right? So V final minus V initial is W external by Q. V final is final potential and V initial is initial potential, right? So one more relation I am going to write, the relation between potential and work done by external, right? In another one we are going to write relation between potential and work done by electric field, right? So note it down. So that one I'm writing here, okay? This much space is available, so I'm able to write it, okay? Relation between potential, right? Relation between potential and work done by electric. Relation between potential and work done by electric field, right? Relation between potential and work done by electric field, right? So electric field is internal, right? Electric field is internal, right? So further we can write V final minus V initial is equal to W electric. W electric means work done by electric, right? And divided by Q, right? And here 1 minus will come. So this is the relation between potential as well as work done by electric field. This is work done by electric field, right? So you are able to remember here there is no minus sign, but when we are going to calculate work done by electric field, there will be minus sign, okay? And next we are going to write relation between electric field and potential, right? Relation between electric field and potential, okay? Relation between electric field, right? Relation between electric field and potential, right? Potential, right? Okay. So what is the relation? Now see again. Now I'm going to engage electric field, right? And potential, right? So further we can add V final minus V initial, right? Is minus of E dot R. Minus of E dot R, right? I know you are getting confused from where this formula is coming, right? For that, you can see here work done by electric, right? So work done by electric. So from this expression we are able to find this formula, right? So suppose in this one we are going to take two topics. In this we are going to discuss two subtopics, right? In first one I'm going to take uniform electric field, right? So relation between electric field and potential. So in first one is in uniform electric field, right? In uniform electric field, right? So right now I'm going to talk about electric field, right? So uniform electric field. This is your uniform electric field, right? Uniform electric field. Okay. And suppose this is your initial position, right? And this is your final position, right? And this is your R vector. Okay. Initial position, final position, R vector, right? Okay. So you can see here. Suppose one charge Q is moving from here to here. Q is moving from here to here. So work done is, so how much force acting on Q? Suppose the electric field is E, right? So force on charge will be QE, right? Force on charge will be QE, right? Now you can see here this charge is in an electric field, right? So some force will act on that charge, right? And that force is how much? QE, right? So that force is, so now I'm writing, okay? Force on charge Q. Force on charge Q. Force on charge Q applied by electric field. Applied by electric field. Electric field is F, right? And this F is what? Q into E, right? Now force is known, R is known. You are able to calculate work done by electric field, right? So work done, now work done by electric field. Work done by electric field is W electric, and that W electric is F dot R, right? F dot R. So further we can write it F dot R, right? And F is calculated. How much is the F? Right? F is how much? QE, right? Yes or no? And you know the relation. What relation you know? You know this relation. V final minus V initial is minus of W electric divided by Q. I already written this relation, right? So W electric is this much coming, right? So just substitute the value. So QE dot R divided by Q. This Q and this Q is cancelled, right? So what value is coming? Dot R is coming, right? So somehow this is proof of this expression, right? So from where this one is coming, this is clear to you, right? Okay, so next I am going to discuss relation between electric field and potential energy, right? Electric field and potential, right? Relation between electric field and potential for non-uniform field, right? For non-uniform field, right? This was for uniform, right? So next we are going to discuss for non-uniform, right? Okay. So next one is non-uniform relation between electric field and potential for non-uniform electric field, right? For non-uniform electric field, right? For non-uniform electric field, right? Now you can see here, this is your non-uniform electric field, right? So electric field is existing like this. As you see, this is your non-uniform electric field, right? Suppose this is your initial and this is your final, and again we are going to find change in potential, right? So change in potential is final minus initial, right? And that final minus initial is that final minus that V final minus V initial. V final minus initial is integration of minus E dot dr, right? Okay, so this relation is for non-uniform, right? So just try to remember it, okay? Some more relation also I'm going to write, okay? So just see what is that. So first you write this one, okay? And then I will discuss that one, okay? Okay, so some more relation I'm going to calculate. Just see what is that. A small change in potential. A small change in potential is what? E dot dr. Yes or no? Right? A small is this one, right? And you can see E is the electric field, right? Electric field can be written in vector form, right? This is already in vector form, right? Suppose I am going to write in different component, right? So further we can write EXI plus EYZ, right? Plus EZ K, right? And this is your dr dot dr. Dr is what? Dx I dy j and plus dz k, right? So if you are going to multiply, what value will come? Ex dx plus ey dy and ez dz. I hope you know this expression, guys. This one is already discussed in. So this one is given, right? Now a small change in here one minus sign will come, okay? TV one minus will come, okay? So here also minus will come. So here minus will come in multiplication of all these quantity, right? Yes. So finally here this plus becomes minus, this plus is also becomes minus, right? So this is your relation, okay? Now a small change in potential, right, due to a small change in x only, right? A small change in potential I am writing with del v, right? A small change in potential del v due to a small change in x only, right? Okay. So a small change in, so from here you can see a small change in x only, right? That means there is no change in y, so dy is 0, right? There is no change in del, right? So dz is 0, right? Okay, so this term is 0, this term is 0. Why? Because dy is 0, because only change in what? X, y is not changing, right? So further we can write here a small change in v is dv, and due to change in what? X, okay, and a small change in x is del x, right? So further we can write from here Ex is equal to del v by del x, and one minus sign will come here, right? Here also minus will come, right? So from here you are able to find electric field if potential is given, right? Okay, if electric field you are able to calculate if potential is given, right, by differentiating that one, right? Similarly we can write Ey is what? Minus del v by del y, right? And Ez is what? Ez is del v by del z. So these three formula you have to remember. So with the help of this formula you are able to calculate electric field if potential is given, right? So this is all about today's lecture, okay? In next lecture I will try to find potential due to a spherical cell, okay? So that's all for today, okay?